horizontal component to be 12 meters, the magnitude to be 17 meters. About 34 centimeters there. You know, it looks like all of the answers there. Yeah, we want our horizontal component to be 12. We have a vertical component, and the resultant is going to be 17. What do I give you? Sine, cosine, tangent? Cosine, yeah. We have adjacent and hypotenuse, inverse tangent, or inverse cosine of 12 over 17 should be. I'm sorry. A little bit more to this. This is a degree side there, I should say, 25 degrees south of east. Notice you can round on something like this because it's really multiple choice. Since there is a multiple choice part on the AP test, it's good to know that sometimes your answer may not match up with one of the answer choices. Maybe when you drew this, you drew the vertical one first and then this one. All right. Notice it's going to give you a different angle measure. It'll give you 61 degrees. So your answer is going to be west of south, right? And then you look at all the answer choices, and that one's not on there. I like 61 degrees, but it needs to be west. How can you match that answer up with that? The opposite, so they need to add up 90, right? The complementary. So subtract it from 90 and then switch it. Should match up with one of the answers. Everybody get that one? A little bit more work on that one. Tell you what, let's go ahead and stop there. Because I want to talk about the lab a little bit. We'll come back to that next time. Go ahead, get your lab out. We collected data last time. You're supposed to go ahead and draw a good graph last time. We did the whole front side. All right, back up here. The back side, over on the back, up at the top. Notice on the front, when we sketch the curve, kind of what shape was our curve? Like that, yeah. Quadratic, right? Kind of parabolic in shape, therefore it was a quadratic, which is modular. Almost always on the AP test, when it's asking us about graphs, you'll graph the data set first, but then we'll want a linear relationship, and then we'll want to interpret the slope of that linear relationship. So obviously on the front side, we don't have a linear relationship. So we want to form that into something that is linear with the same variable. Does that make sense? A little bit, no. All right, let's do it together. We're going to finish the class together. Not today, not today, but over the next couple of class periods, we'll finish this one together, and then you're actually going to do an old AP test, an AP problem where they ask it. All right. So number 2 is asking us if only the variables d and t are used, what quantities should you graph in order to produce a linear relationship between the two quantities? D represents what in this case? The distance that the ball rolled down the incline, right? So distance and time with something that is accelerating, right? Can't simply use distance equals rate times time because we have a changing rate. Look at your formula sheet or think back to honors physics last year. What is a formula that relates distance traveled to time? Define the first, because I don't know which one. One broad detail is that what you mean by the first one? Yeah. All right, we'll go with that. All right, notice the notation is a little bit different than I think you saw last year. X represents the position. V sub 0 instead of V sub I for the initial velocity. That's the formula we want to be thinking about. If the initial position is 0, right? So x sub 0 is 0. What was the ball's initial velocity? Okay. So wouldn't this be a relationship between distance and time? Obviously, we're using d instead of x. D equals 1/2 at squared. That makes sense? which if I were to graph that, time versus distance, t is squared, right? Does it make sense that we got a parabola? Yeah. All right. If I want that to be linear, instead of graphing t versus v, we would graph t squared versus v. All right. Y equals mx plus b. All right. M is the slope, which is going to be right in here. We'll talk about that in a little bit. If I make x t squared instead of just t, I'm going to have a line. You follow? All right. So the two variables they're asking for here are d distance and t squared. That's what we want. We're going to graph, instead of time versus distance, we're going to graph time squared versus distance. And that, instead of giving us a quadratic relationship, should give us a nice linear relationship. Questions on how we come up with t